Hi, everyone. Welcome to the SageMaker Friday on low-code machine learning. We're very excited today. I'm personally Kosti Vasilakakis. I join you from the SageMaker team, and I lead the go-to-market strategy and the product growth of the capabilities that we call low-code, no-code. And today, we're very excited, myself and Michael, to walk you through how you can actually and discuss over how one data scientist or a team of data scientists can experiment much faster with low code, no code technologies that we have built as part of AWS. Michael, I'd love to introduce you as well. Michael Shea is our senior AML specialist solution architect. And if you don't mind, I know you'll be doing some great stuff today, but I'd love to get the chance to introduce yourself as well.
Yeah, thanks, Kosti. My name is Michael Shea, and I'm a data scientist by trade. So, really, looking forward to showcase and to discuss with you how low-code, no-code ML can do for data scientists.
That's perfect. So for the purpose of this discussion today, maybe potentially a little bit of a debate, I'll come in and I'll represent a business person, and Michael will be, of course, our data scientist. And we would like to showcase how that interaction between business and data science teams are and some of the issues there, as well as some of the solutions we've brought to market that can help you drive scale across all those machine learning initiatives that you have. So I'd like to first ask Michael, so what would you say are the biggest challenges that you see when you are doing data science projects, or when you see your customers doing data science projects, and especially with regards to machine learning experimentation?
Yeah, I would say that it's twofold. One is really requires very deep understanding in data science, machine learning, and mathematics, statistics, and so on and so forth to properly prepare data and to build models, right? And there's so many different ways of building models, so many ways to types and chops of the models. Really requires not just knowledge, but also experience and when to use what tools to achieve the business outcome that the team is looking for, right? That requires experience and also deep expertise. Number two is experimentation can take a lot of time because machine learning, as we all know, is an iterative process. And to make sure that you're getting the most out of the machine learning models, and also the way that you process the data requires a lot of iterations, and also multiple people working together. And it's just a lot of resource, and it's very time consuming. And that's where most of the team, even including ourselves, are struggling when we're working in a real world machine learning use cases.
Yeah, I mean, I fully affiliate with that. I've wherever I've been, be it internal or external teams, and it really requires a heavy lift. It's a steep learning curve, and it's not that easy. It's just not easy, and it's very iterative. And what I've heard is that our data scientists and many of our customers, or most of our customers' data scientists, are truly oversubscribed. They have a lot more in their plate that they can do, and those needs are only increasing, which is healthy. I mean, it's exciting that customers are using more and more data science to solve their problems, but that falls into the hands of the data scientists. So the other thing I've heard extensively is that it's not as quick to ramp the skills of non-technical experts like analysts to become really a data scientist. So it's not that we can really upskill anyone to become a data scientist. So it's a little bit of a process that we try to a little bit of a pain point that we try to alleviate with what we call low code, no code technologies. So I'm quite excited
Absolutely.
to have this discussion today. So maybe
Absolutely.
we discuss today what we'll have as use cases. So I know it's quite aggressive in the next few minutes to drive 2 use cases, but I personally was hoping in the next in this session to solve for 2 of them, one for tabular data as well as for computer vision data. And more specifically, I was hoping to do a model on how to predict loan defaults. We have some data from Lending Club, and I'd love to be able to showcase how we can very quickly understand the data as well as build a model. And then I would love to also, if possible, build another model for computer vision, and more specifically on top of the Hurricane Harvey data set that Allstate and State Farm were using to actually, when Harvey happened, they used drones to really predict which buildings were actually damaged to expedite the process of giving back and satisfying the claim. So I was curious, is it possible to, in the next few minutes, build 2 models and do it in a good, high quality way?
Yeah, absolutely. I mean, Costi, you are very ambitious and very aggressive, and this is exactly we love to take on the challenge. The data scientists love the challenge, and in terms of how we can do it, right? So we first need to understand what is the life cycle of a machine learning process. First of all, we started out with the business requirement, as you just stated, right? So the 2 use cases, very clear business requirement, and how do we convert that into machine learning questions or problems so that we can start the machine learning model building process, right? The first step is the business requirement. The second step then is to how we can prepare the data and how we conduct the feature engineering. Once machine learning requires. Some machine learning models requires data to be in a certain shape and form. And so data preparation and feature engineering will help and prepare the team towards that directions. And now that you have data prepared, you're into the model development. And then that's a time where you are training and tuning the models. Once the model is being built, and you will be deploying that models into production and for actual business requests, right? So that's the end goal we want to achieve, and to help business to to handle situations in a much robust and larger scale and faster, right? Using machine learning, and with this iterative process, Amazon with AWS offering on low-code, no-code, dedicated to 2 different type of teams, has really aimed for solving this problem in a fast and robust way.
So what is, I see these offerings, like you mentioned, low code, no code, ML. I see for business teams, I see for data science teams. So what is exactly low code, no code, and how can help the different team members?
Yeah, so with that life cycle in mind, low code, no code really means that you don't need to write too many codes to achieve this. That typically needs a lot of coding from data scientists, developers, dev engineers to achieve, right? So instead of writing codes, the interface is simple and easy to use, point and click, and that allows you to quickly go through these processes without coding, and also not requires deep understanding into machine learning, and really help accelerate the process.
So I see some difference between what we at AWS have for business teams and what we have for data science teams. And I do see also we'll focus on the data science component, but let's make sure we're clear on what is that is aimed for analysts and what is that is aimed for data scientists.
Yeah, so Amazon SageMaker Canvas is a no-code workspace for analyst team or business team that with a very, very rich and easy to use interface and point and click to quickly process and help you find out the data set, figure out how to run machine learning models, and then to train and tune machine learning models behind the scene, so that you don't really need too much worry about the machine learning part, and then you'll be able to use that machine learning models for actual inference or predictions or requests. But for today's focus, we focus on data science teams or data scientists. Amazon SageMaker Studio, which is the first IDE for machine learning, also has a couple of different features that allows us to not write too many codes to achieve the final outcome. And these are for data SageMaker data wranglers for data preparations and feature engineering, and also the autopilot, which is SageMaker Autopilot, which is a AutoML capability that automatically prepares data, run the feature engineering and tune the models, and then deploy the models for tabular data and time series data sets for inference. Right? We also have SageMaker Jumpstart, which is a feature that offers solutions, pre-built solutions, and model zoos of pre-trained models and easily tunable state-of-the-art, computer visions with natural language processing models for use cases that typically requires from data science a lot of effort from data scientists. But now with these features, we'll be able to quickly get to the models and get to train models without much coding and deploy the models in production for use.
Mm-hmm. Very, very exciting stuff. So I'm personally quite eager to see how we can use those low-code, no-code tools that we have built for data science teams to actually solve for the two use cases that we laid out, the tabular as well as the computer vision one, and how easy will that make machine learning? How easy will they make machine learning?
Yes. Shall we start digging into it, Cosby?
Let's do it.
Yes. So let's tackle the first use case first, the loan predictions. So let me quickly, describe the situation and the use case. So this is the data sets, and this is really, a view of each of the customers that a financial service company have, whether they they purchase or they use a certain loan product and where is their loan status. So, for example, in this spreadsheet, you can see this loan status and also the information about this loan that this customer had purchased or has used. So, such as loan amount, interest, and the the customer's credit history and so on and so forth. And also, there's another piece of spreadsheets that captures the annual income of each of the customer and their home ownership status, right? So with these, what typically, and this is the structured data set that we are talking about, tabular data sets. And if you recall, in the tool sets, that data wrangler is actually a very good no-code, low-code solutions to handle this structured data. So let me bring up the data wrangler file. So in SageMaker,
so what is it that you usually do when you see this data set? That what would you like to do, and how, for example, data wrangler can help you do that?
Yeah, that's a great question. So typically, when we're working with these structured data, we've got to first understand the relationship between the features and the target variable, right? So a lot of things we need to look at. We need to first find out where the data sources are, right? So number two is we need to, for example, in this use case, there are multiple different data sets coming into for our machine learning use case. How do you join them and how do you process them? So that you have a better overview of a customer behavior. And third is to perform some exploratory data analysis. Trying to understand, like I said, the correlation between the features and also towards the target variables, and how to understand whether machine learning is a good fit for this data sets. And lastly, what data wrangler really helps is that it helps data scientists to prepare data easily and very fast. So it helps you transform the data into a way that machine learning models can consume. So I would say that this is typical what how data scientists would use data wrangler for.
That's perfect. And I do see S3 and Athena, but is there any other data sources you can bring data from?
Yeah, so S3 Athenas are typical, where the data sets are located for within enterprise environment. But also, if you look at the right side, Amazon Redshift is also, a integrated, source of data that you can pull from, and also Snowflake and Databricks. These are two other places that you can data scientists can pull data into Data Wrangler to process and to start analyzing and start transforming the data.
That's great. Cool. Well, can't wait to see that in action.
Sure. So as I just did, I pulled up a data Wrangler flow file, and this is the first thing that you will look at. As I said, we need to find out where the data set is. I already upload these these two tables into S3. So we can, load the data from S3 location. And let me pull the locations so that I can quickly locate the files. And so these are the two files I'm going to import into. And we can first, inspect whether this is what we expect. Yeah, this is exactly what we have locally. So I'm going to import that into the data sets, and this is showing that that then is switched to a data flow view and to show that what data set has been included and right now is automatically figure out the data types. And now come back to the import part, and because we need to find out another file. And this is exactly what we looked at before. So I'm going to import it. So this is the data sets that we have. And the first thing we need to do to have a better overview of a customer behavior is to join them. So joining in Data Wrangler is very easy. You right click on the plus sign, click join, and you can join the other tables together. Let's configure the join, how we like to join them, and we can select inner join, left or right join, or full auto join. Let's go full auto joins, and we select the IDs very easily. You can join the two tables together, and we can preview the join output. And now we see that it's a main the whole spreadsheets have been concatenated together or joined together. So we are ready to add them, and then we can move on to start, what we call EDA, exploratory data analysis with Data Wrangler.
That's perfect. That was very fast. So what is it, Michael, that you would like to know from the data? Like, what is the first things you will see as part of the exploratory data analysis, and how is Data Wrangler helping you there?
Yeah, number one thing that data scientists would typically do is to look at the distribution, look at if there's any trend, do some plotting, right? Understand the distribution of the data, whether there's balance or imbalance, and whether there's any correlation among features towards target variables, and so on and so forth. And so if you look at the analysis that the Data Wrangler can have, it covers a lot of different features, right? So, you can create visualizations, histograms, and also feature correlation and multicollinearity is something that I will, data scientists will also look at, trying to understand if there's any redundancy in the features in the entire, data sets that might harm the models. And most importantly, I would like to point out is the quick model. So Data Wrangler also uses machine learning to look at your data and try to give you a sense whether your data set has any predictive power towards predicting the target variable, which is very, very good first intuition for data scientists to start their data engineering or feature engineering effort. And so
from what I understand, a quick model would be like a benchmark for you to iterate on the feature engineering and help improve the model that you use afterwards.
Yeah, you can definitely serve as a baseline and to help you understand, how, what kind of expectation should we have, and maybe we can have high expectation or low expectation, and kind of level set on, on the data set without much coding. And this is where the low code, no code is really coming into play.
Perfect. So which one do you want to do first? I'm quite curious to see this in action.
Yeah, so number one is I would like to see the distribution of the loan status versus the loan amount. Trying to really quickly see a histogram of the loan amount by status and see what kind of the distribution there is. So let me just bring up a quick histogram, And x-axis select the loan amount and the faceted by loan status. Here is a visualization of the histogram that we're just looking at, and we can quickly draw a couple of conclusions. One is these are faceted by different categories within the target variable, and there's way more fully paid customers versus the customers who are still paying the loan. So one conclusion is that this data set is still it's a little bit imbalanced in terms of the categories into target variable. But number two is that you can see the distribution of how many people are taking out loans in what amount. Kind of give us a first good understanding of the data distribution. But this is just an example, right? So we're just looking at loan amount. You can definitely look at some other distributions. And the next thing that I would like to take a look is to see if there is any multicollinearity in the data set, meaning if there's any features that are producing similar or correlated information in the data set. And why this is important, because some of the machine learning models, especially the linear models, assumes the features are independent with each other. So having some features related or correlated to each other might harm and might violate the assumptions of machine learning models, and then therefore harm the performance of the model. Also, interpretation or explainability of the models. So this is also typically what I would look at in the first place. And multicollinearity is something that Data Wrangler also supports. So it really gives you a quick view what kind of informations are being coming into the data sets, and if there's any correlations or even redundancies. And we can really quickly see this. And for example, in this data set, the variance inflection factor, which is typically used to calculate the amount of information coming from each features, how they correlated with each other, and also if there's any redundancy in the features. And anything above 5, which is around here, consider there's some correlation with other features. And very quickly you can see IDs, and which is just index, which we haven't dropped them, is having a lot of correlation. Of course, they are correlated with another set of IDs after we join the tables, right? So another correlation that we learn is that interest rate, for example, can be inverse correlated with the credit grade of a customer, right? Also the installment amount can also be correlated with the interest rate, right? So the higher the interest rate, you have higher installment, and also correlated with the loan amount. So all these information are actually highly dependent on each other, and also providing similar information with each other. That's what this multicollinearity analysis is providing us, and we can quickly confirm with our intuitions.
That's really great. That's perfect. And what do you usually leverage? Like I saw a couple of those. You brought collinearity, you brought a histogram. What else you would like if you was the first iteration of feature engineering? What else you would put into?
Yeah, absolutely. So my favorite one is also the quick model we talked about before, right? So this SageMaker Data Wrangler really uses also machine learning underneath, and we can just simply select the target variable, which is the loan status, and it will start crunching the number for us and trying to give us the first sense how this data set, what kind of predictive power does this data set provide to a machine learning models in predicting the outcome. So this is what I also like to do, and also help us to understand what kind of baseline, as we just talked about, and we're seeing actually now things in action, how a quick model can help us. So within a couple of seconds, the results will come in.
Perfect. And I guess as this is producing the outcome, then the next thing you want to do after the insights you got is, I suspect, to add transformations, right? And does Data Wrangler help you with that?
Yeah, absolutely, absolutely. So data wranglers, not just the EDA, right? The exploratory data analysis transformation is made very easy for typical tablet or structured data machine learning use cases. So with Data Wrangler, it offers many more than hundreds of built-in transformations that allows you to quickly transform the data without much coding, but also allows the flexibility in using your own custom coding to transform the data. But let me come back to this analysis because the result just comes in. So here we can see that the model has achieved an F1 score of 756 on the test data. And essentially what this quick model is doing is splitting data into a training and testing splits, and throwing the entire data set with the select features into machine learning models and produce these results. And what it also shows is the feature importance from each of the features. And of course, this is by no means a hygiene, clean data set. So it includes a lot of noise, for example, the IDs, but you can quickly see the importance of each of the features that each of the features brings in, and the model performance. So let me save this as a baseline and come back to the data flow, and so we can start the data engineering as we just talking about. In order to add a transformation that's add a transform, and so this is where we'll start analyzing and also transforming the data. And as I was mentioning, Data Wrangler offers many different type of data transformation out of the box, so you don't have to write any code. And the number one, and it also supports various types of data, so time series data, numerical data, categorical data, and also text data. So these are the four main types of data that Data Wranglers supports and and can process. Right, this should really covers the entire spectrum of the data sets that data scientists typically work with in the tablet data.
That's perfect. So yes, I see some ideas. I'm very curious to see how you can process some numerical data and what kind of also numerical transformations we can bring in.
Yeah, so let me first start with the most obvious, because it contains the IDs that are completely redundant. So let me draw some columns first, like IDs, and we can multi-select the different different features or columns. So the two IDs, and what we also learned is that there's some gradings that might be redundant. So grade and subgrade, this is a little bit more fine-grained grading, so we can just choose one. So this, you can quickly select multiple columns and perform the same operation. So let me drop 3 columns, and that's the first step that I do. And then I would like to also look at if there's any outliers within our numerical data. Right, so if there's some errors when inputting the data into the database or into the system, how do you find out those outliers, right? So handling outliers is also something that can be easily done for multiple columns within Data Wrangler. So if I choose the loan amount and also the maybe the interest rate, there might be some outliers in the interest rate, and I can quickly see how I want to fix it. I would like to just clip it to a certain range, and I don't want a 4 standard deviation. Let me fix it to 3 standard deviations so that everything is within the 3 standard deviation. That translates to 99.6% percentile. So this is how you can analyze the outliers and find out the outliers and clip it at a certain range.
It's pretty fast. That's awesome.
And the next thing I like to do for numerical data is perhaps the normalizations or standardizations. So in process numeric, we can scale the features using standard scaler, robust scaler, min and max. using different ways of standardizing or normalizing the data sets. And again, I can standardize or normalize the long amount, various of features. Anything that is numeric that we like to standardize, you can choose it here. But keep in mind, because in later after we prepare the data, we're going to send this data into SageMaker Autopilot, which is all ML capability from SageMaker. Autopilot also performs these standardizations and these processings for us. So just keep that in mind, and knowing that either we can do it here or Autopilot handles the data normalization for us. But quickly using Data Wrangler, we'll be able to normalize the features in this way and center at the mean and scale the standard deviation into 1.
So you're suggesting for any data scientist out there that is planning to use both Data Wrangler and Autopilot together, no redundancies, focus on other transformations. From what I understand, there's hundreds of other transformations within Data Wrangler they can choose from to, in a way, enhance what is already provided by our AutoML capability.
Yeah, absolutely. So you can definitely apply some custom and also more advanced or transformation that fits into a specific business logic, right? So this is something that Data Wrangler really allows a data scientist working on a business use case to achieve.
Perfect. And I see you see some categorical. What can you do with text and categorical values?
Yeah, absolutely. So let's start with the text data, because we do have a column that contains freeform text, which is the employee title. So this can be a great example for us to compute the text to transform the text data. So for this column, let me just featureize the text, because what I like to see is I like to vectorize it in a way that machine learning models can consume this freeform text better. And one way to do it is to featureize it or vectorize it using TD-IDF. The TD-IDF is a very common way to, based on the frequencies of the text and co-occurrence of the text, and featureize the text into a feature factor. And here we can choose and slightly modify the frequency, minimum term frequency, and then we can leave everything default and apply the IDF in the end to really vectorize this employer title column. And there are two output format, vector and columns, but I would like to use vector because it's a much succinct way of encoding information. If we use columns, you'll blow out to way too many columns for this freeform text. Let's quickly preview that, and we can see all the way to the right. There's a new feature factor feature or variable called feature title feature, employee title features. That has the vector form of the embedded or featureized or vectorized feature of the employee title. So this is essentially how you would do that with the featureized text. But in terms of categorical, and that's another very, very common feature format, right? So in code categorical, we can use either ordinal encoding, one-hot encoding, or similarity encoding to encode the data. And typically, and very commonly, for example, there's a columns on the right side, home ownership, right? That's transform this using the one-hot encoding, and what it does is going to home ownership. What it does is going to one-hot encode this columns into multiple columns. So again, you can choose vectors, but let's just show what the output style of columns would look like. So all the way to the right, we'll see home ownership now has been blown up to multiple columns. Each column encodes whether each customer has, is renting a home or is right now paying mortgage or owns the home outright. So this is essentially, the one-time coding that their Wrangler does for us.
Mm-hmm. So you mentioned before that there was a big imbalance. Like, how could we solve this with Data Wrangler?
Yeah, so this imbalance, as we see in the loan status, we see, this data set is predominantly filled with, customer that has fully paid off the debt, right? So, and there's some dangers with it when running the machine learning models, as most of the data set or information, from this data set is coming from one specific group of customers, right? So your models is going to be very biased towards this group of people rather than the other type of customers. So here's balanced data that is suited for binary classification use case to oversample or undersample certain group of loan status customers. However, this right now is a multi-class classification because it has 3 classes. So we might need additional preparations to either group the charge off and current into the into customers that are still paying for the loan versus the fully paid. So make it into a binary classification. Excuse me. Then we'll be able to use this balanced data to balance or to either oversample the customer that is still paying the debt or undersample the fully paid off customers.
Got it.
So here's the options that we can do.
I'm just curious now, if this data set had a time series component, like how would we go about adding transformations? And not only that, if you wanted to bring some custom transformations that you yourself built, how could you do that in Data Wrangler?
Yeah, so in this data set, we have 2. It's not necessarily time series, but it has timestamps, and this requires some custom transformation. Well, let me first, first address this, this particular features. Looking at the issue and earliest credit line, one very intuitive, features that we can come out of these 2 columns is the length of the credit history of these customers. So we can, build a new features on top of these 2 timestamps using custom transformation. So in custom transformation, we can, put in limited amount of we can put in codes, and this is where the limited amount of local no code that we need to put into a Data Wrangler to come up with something sophisticated. So here we can put in the custom code to calculate the credit line history in month, right? So we can calculate new features using this custom transformations to produce new features that will perhaps provide more information than just timestamps, than just these 2 timestamps. So on the right side, we have the new features, which encodes the length of the credit history in months. In terms of time series, to another side of the questions, right? So assuming that this data set is not a time series data set, but if the data set is a time series data set, in Data Wrangler, we also have a couple of transformation that allows us to transform the time series data. We can group the time series by certain months or certain time period. We can resample and we can perform different actions, transformations with the time series data using this time series transformation from Data Wrangler.
That's awesome. That is a lot of transformations and analysis very quick. And I know we are getting close to time. I'm just curious, you mentioned autopilot on top of what you've already done for data preparation. How can autopilot help you? What does that do?
Autopilot, let me first mention that we need to export the data so that autopilot have the data set to work with. Let me first export the data into this location so that later we can throw the data that we just prepared into autopilot. So now it's exporting to S3 location. Once the data is being exported, we can start, preparing a autopilot experiment in SageMaker Studio. So to bring up a new autopilot experiment, it's just in the file new experiment, and we have a new experiment. So what autopilot does is that I'll show once we start an experiment, it will show a very clear view of what each step is doing. But in a nutshell, it's trying to look into the data, trying to analyze the data, and also figure out the pattern within the data and apply the appropriate transformations and feature engineering in order to maximize the model, model performance. And also, when training the machine learning models, it will fine tune the models, or start tuning the models in a way that in a way that will maximize the performance in predicting the target variable. And all this is being done within one single autopilot. But not only those things, autopilot also generates explainability reports to help you understand and also unbox the black box that we typically say, to help you understand how machine learning model is being created and how machine learning model is making decision in predicting a particular output.
That's very intriguing. I'd love to see this.
So we need to set up an experiment, right? So let's first set up this experiment and get it going, and we'll see autopilot in actions. So this experiment is a long predictions, and just like to give a suffix so that we can start the experiment with a unique name. So the first thing we need to provide is the data sets. We have previously uploaded data sets into Data Wrangler, right? So out of Data Wrangler into autopilot. So we can grab the data in S3, find out the location, and provide it in here. And autopilot automatically detects and read into the CSV and find out all the column variables. And so we can choose the loan status as our target, and we also then we can specify the output location for this job. And so that autopilot will save all the output into this place. And here's all the deploy. Once autopilot has been completed, you automatically deploy a best model into production or into SageMaker a real-time endpoint to start taking requests. So we can either choose to turn it off, or you can leave it on, so that we'll have models deploy right after the training job completes. So let's leave that on. And one thing I'd like to call out in the advanced setting, the optional ones, is the machine learning problem type. Autopilot automatically detects the problem type, which is in this case a multi-class classification problem. But also you can kind of choose by yourself what the problem type it is, and also choose the objective metrics to fine tune the models. So we'll leave as accuracy. We can just choose auto and to start the model training job. Let's just create that and get it going.
And these are the actually steps you're referring to as well: the pre-processing, the feature engineering, model tuning. It's exactly what you were walking us through.
Exactly. So this is exactly all the steps that autopilot is going to run through, and it's going to take some time, but it's going to automatically figure out the pattern within the data, come up with the recipe that customized for the data sets, and also your chosen target variable, and to start crunching the number, start train the model and tune the models, and then understand how the models is making inference, and provide a feature importance and also performance summary, such as confusion matrix and so on and so forth, and before you deploy the model. So you have full visibility in how the model is being trained and also how the model is performing. And as a cooking show, let me just switch to a model that has been autopilot job that has been kicked off and finished. And so here's a training job that has been done before. A couple of things I want to show here is that here is what we call leaderboard of an autopilot job, and it showcases how many training job it has started, and what are the accuracy or the performance over these different iterations of training jobs are increasing. So you can see that it's pretty much getting stabilized at 0.83 accuracy in these training jobs, and it determined that this is the best model for us to deploy and also to analyze the explainability and performance of this model.
I see. That's great. So it gave you all those different options that it evaluated, but how can I actually trust that this best model is actually best? What does it mean?
Yeah, so let's look into the model in more detail, right? So what Autopilot generates as part of the explainability report is the feature importance and performance report. In feature importance report, it shows you what features are given the most importance, or given taking the highest weight in making a decision to predict the charge of customers, or even fully paid customers, right? So current customers, these are three different groups of customers in this data sets, and what are the features that would help predict the customer in that group, right? So it offers this as an insight, and also more information around the metrics, performance, and also the confusion matrix, right? So you can see how the model is predicting your data sets, and how it's trained, and also how it's predicting on the validation set or test set, and if there's any misclassifications in from group A to group C, or from group B to group A, and so on and so forth, to help you understand more before you actually put the models in use. And of course, you can download these reports into PDF and for audit purposes.
Oh, that's great. It gives me a lot of information that I can share with my leadership, or can myself understand. But what if I wanted to understand and inspect the code itself?
Yeah, so for hardcore data scientists, you might be very curious about what's underneath, right? So I guess you have that instinct as well, Kosti. So SageMaker Autopilot also generates the notebooks that uses to figure out your data patterns and so on and so forth in a separate notebook, and really try to unbox the black box, and really make sure that you have the clear visibility into how the decisions are being made and based on what criteria. So here's a notebook that shows all the information about your data sets, and here's another notebook that shows you the actual codes that perform the data engineering, perform the model training, model tuning, and so on and so forth. And really, for people who needs to dive deeper into the code and to understand how it works, and also to perhaps make some minor adjustment, and you'll be able to completely own that process by importing the notebooks and modify the notebook and rerun the jobs.
That sounds like a huge productivity booster. I guess you do this extremely quickly, automatically, and then you can work off of that. But what if I wanted to deploy this? Like, how easy it is to bring it to production?
Yeah, so as we showed you, when setting a job, you have the options to choose the autopilot to automatically deploy the model. So once the job completes, you do have a model ready for you to make inference. But if you do want, you can choose. You also have the options to choose other models if you, after certain explorations and analysis afterwards, reading those reports and understand, oh, okay, so another model might best suited for our business use case because it's higher precision or higher recall. You can choose other models and click on deploy models. And here you can easily fill in the form and start hosting the models in SageMaker real-time endpoints.
Cool, that's perfect. So I know we are running out of time, and as you said, I'm a little bit ambitious. I wanted to cover a computer vision use case as well. Maybe we showcase that, and for the audience out there, feel free to ask questions um, at the Q&A box at the bottom. We have moderators that can help address those as we speak, and then we'll have a little bit more time in the end to also address Q&A again through the chat. But let's go over the computer vision use case, Michael.
Sure, the computer vision use case with SageMaker Jumpstart can be really quick. So just a quick problem statement. These are the images, damaged images, houses that are damaged, and the aerial imaging from these houses, and also aerial imaging for the houses that are not damaged. And with these data sets, we're going to build a models using SageMaker Jumpstart Model Zoo. We can quickly browse all the models within SageMaker Jumpstart. We can see the models. There's so many different models, more than 300 models for you to choose from. But also you can choose from the problem types. And in our problem statement, we're trying to predict damage versus not damage, right? So this is essentially a image classification use case. So we can choose image classification model zoos and select one of the models out of these pre-built models, and that allows us to train, even fine-tune for our specific use case. So we can choose one of the models.
Just to make sure I understand, Michael,
yes.
you don't mind going back to the list of different models? It sounds like that the model zoo is like state of the art, like out of the box open source models that we offer our data scientists out there. Instead of them writing that model, they can just click on it and they can use it.
Yeah, absolutely. So these are definitely open source, as you mentioned, from TensorFlow Hub or PyTorch Hub. So, but here in SageMaker Jumpstart, we create this portal for you to easily find out these models and for use, when you're building within the SageMaker Studio.
Can you access those models through an API? I know data scientists want to just go through the API itself.
Yeah, the API is being a new feature being exposed to developers who wants to access the models and pull out the models for fine-tuning purposes, or model deployment purposes using API or SDK rather than point and click experience here. So that would really help developers who want to use code to use these models.
That's perfect. And from what I understand, you went to image classification, you click on it, and then what is after that?
Yeah, so there are two options with this model. You can either deploy the models to actually start making inference for a particular use case, and because this model is trained on ImageNet datasets, so you'll be able to classify many different objects in our lives directly. But for our use case, we need to train a model for a very specific use case, because here we're predicting damage versus not damage from our aerial imaging, right? So once we provide the data that has the images set up in a way in the folders and classes behind classes as the subfolders, we'll be able to start a training job using, for example, P32X large with GPU instances to fine-tune this data set, fine-tune this model towards this data set. And you can choose the hyperparameters and start training. And once the model is being trained, which is, again, the cooking show fashion, we will have the new model, a fine-tuned model for use, and we can, plug into an existing code and starting, for example, I'm using this model that is previously fine-tuned, and we can quickly make inference and see if the models are making proper predictions or not, and see these images that are not these houses that are not damaged, and the model is actually really predicting that they are not damaged, and these are the test data that the model has not seen before. And for the another set of images that are damaged, the models can clearly tell us that, hey, they're damaged, and it shows that the model is being properly trained to handle these set of images and with real confidence. And as you can see, without writing any code to fine-tune the model, we're able to build a machine learning models that can detect the houses, whether they are damaged or not, from the hurricane, in a matter of a couple of minutes.
You're my superhero, man. Thanks, Michael. That's really impressive. In 2 use cases, in a few minutes, I'd say. Possibly, if we were to run this like in a couple of hours, you're done with those two. That's great. What else do you see of value to you through those tools? I'm just curious.
Yeah, number one, as we mentioned, the challenges that data scientists teams or data scientists have is how much time and effort you need to put in this to build a machine learning models, right? So time efficiency that SageMaker, Data Wrangler, Autopilot, and Jumpstart really offers is in matter of just minutes or even less than an hour, we're able to build machine learning models to tackle two distinct use cases, right? Instead of having an entire team developing for days or even weeks or months, right? So that would be the number one, benefit, or the efficiency gain that we see from this low-code, no-code offerings.
And I'm just curious: are those tools, because I do see the benefits, like time improvement is superb. Is these tools for experts as well, or just non-experts?
Yeah, so this is also great tooling for experts, because it really takes away a lot of heavy lifting in building repetitive codes, or building or writing machine learning models from scratch. It really takes that away and really help you focus on what makes the most impact for your business, right? So expert can really also enjoy the benefit of having less code to manage and to write.
That's great. That's awesome. I know we are getting close to time. Let's wrap this up, Michael. Here, I really appreciate you demoing all these powerful tools. Team, thanks everyone for joining. I really appreciate your time. Do ask questions at the bottom of the Q&A chat. And from what I understand, Michael, we have some assets that they can leverage also in a GitHub repo. What are those?
Yeah, so for people who want to try out these demos that I just walked through, we have all these resources and code samples and instructions in this GitHub repository. You can access through the link, very easy, no code, or using this QR code to scan and to access the code repository. But also, if you have any questions, reach out to us, and we're always here to help. And we have the emails here, and also you can scan the QR code and to start writing and chatting with us.
That's fantastic. So everyone, again, thank you so much for the time. Questions just below. We really enjoyed this, Michael. Thank you so very much. And we can't wait to hear how you're using those low-code, no-code tools. Hopefully, they're making the business teams as impressed as I am with Michael doing this so fast.
Yeah, thanks, Kosti, and this is really fun working with you. And hopefully that everyone finds it useful. And until next time, thank you.
Till next time, thank you all. Appreciate it.
Bye bye.